Hello, I'm Brandon Stevens with EE in a Box, and I'm here today to show you how to install your plug-ins on the end of your extension cord for your project. You can obtain your materials from your local extension office, or you can find them at a hardware store in your town. Inside of that kit that you may obtain from your extension office, you've got a 20-foot cord and also two ends. You've got a male end and a female end in order to install. So I'm going to show you how to install the end on your wire and give you some tips to make your installation a little bit more successful and easier for you to be able to install those cord ends onto your wire. So the very first end that I'm going to show you how to install is going to be the male plug end. Let's talk about tools for just a minute here that we're going to be using for installing the devices that we're putting on our cord today. I've got several different screwdrivers here, and as you can see, we've got tiny screwdrivers, a little bit larger screwdrivers, and then even larger screwdrivers. Now, picking the right tool is the best way to install your device successfully. And picking that tool is important. So very small tools probably don't have the correct size tip to install the screwdriver in the screw to be able to turn it and get it to tighten or loosen. Also, a very small handle, you do not have very much torque power by grabbing that and twisting that with your hand. And so you'll want to select a tool that is better suited for the project that you're working on. Today I'm going to use a larger Phillips screwdriver and a straight blade screwdriver here for working with our project. So I'm going to put our small tools aside since those are not the proper tools that we're going to want to use. The very first thing that we want to do is we want to remove the screws out of the end here, and really we don't remove them, but we just loosen them so that they are free and allow the end of the plug to slide out. Also, we want to make sure that the cord grip is open, but you do not want to remove the screws or any of the components within the end here. If you do remove the screws or any of the components here at the end, we want to make sure that you get those installed correctly and there so that when we clamp that down on the cord, we do not damage any of the conductors or the insulation on the outer jacket of the cord. So if you do take that apart, pay close attention to that, but you do not need to take that apart. Just loosen it up so that you can slide the cord in and out of the end of the body without removing all the parts. So I'm just going to loosen those screws here a little bit. And again, not taking the screws all the way out, but opening those up. And then I'm able to slide the cord through the end and install the wire that we're going to be working with. Before we install the cord through the back body of the plug here, I want to show you one tip that will help you make your installation a little bit easier. If you look at the end of your plug that you're going to be installing here, this plug that is supplied in the kit that's available at your extension agents, we have a gold blade, a silver blade, and a U-shaped gold blade. Now the U-shaped blade is our ground. That is our safety connection for an extension cord and is very important. Our silver blade here is for the neutral, and the gold blade is for the hot or the black wire on your cord. So for the connections, if they are not color-coded like this on your plug, which most plugs are not, you can look at the blade or the screws that are connected to the blade on the internal part of the plug. Sometimes these are color-coded, and as you can see, I've got a green screw for the ground. That's for the green wire and the cord, the ground, the safety. I also have a gold screw here, and the gold screw is for the black or the hot wire, and the silver screw here is for the neutral or the white wire. It is important that we put the right wires on the right connections in order to have the polarity correct for our extension cord that you're going to build. Now, if we look at the end of our plug here, and if I hold this up, we've got the ground here at the bottom, we've got the neutral over here on my left, your right, and then the gold connection over here on my right or your left. Now our goal to be able to install the wires on there, it will be much easier if we get the wires in the same orientation as the blades of our plug. So as you see, if we look at the end of the cord here, I've got the green wire at the bottom, which matches the green or the ground terminal here on our plug. The white wire here, which matches the silver or the neutral connection, and the black or the hot wire, and that matches our gold terminal, which is our positive or our hot connection over here on our plug. So that end would be the best end to install here on this end in order to make the wires match up when we put them in through the back and connect to the terminals. So with that end, we want to put that through the back shell of our plug that we're going to be installing. Push that shell out of the way, and we are going to prepare and remove the outer jacket here and prepare this end to be able to install there on our plug. Now, when we remove the outer insulation of our wire here, the jacket, the yellow jacket on this cord, we want to only remove enough of the jacket in order to free the inside conductors, but not have any of the jacket removed beyond the back of the cord clamp on our plug. So one way to determine how much wire or jacket on the wire to remove, we can use a ruler to measure about the inside depth of that plug. And as I measure here, I've got about 1 inch, so if I look there, maybe 3/4 of an inch would be a little bit safer to remove the outer jacket in order to put that together. Remember that there's a little bit of the plug that goes up inside of the back shell of the connector. So if I were to remove about 3/4 of an inch, that would be a good start to be able to not remove too much insulation or jacket off of that. So if you would like, you can take a Sharpie marker and put your ruler up there and put a mark on there so that you know where to remove that outer jacket to. Now, when we remove the outer jacket, we want to make sure that we do not cut through any of the insulation on each of the individual conductors. The best way that I like to remove the jacket, and you may have a different method that you would like to try, I'm using a sharp X-Acto knife here with a blade that retracts. And what I'm going to do is I'm going to cut lengthwise with the wires so that I'm not cutting around and cutting through each of the individual conductors. So what I'm going to do is gently press down, and I'm going to take that knife and just cut gently through the outer jacket, making sure not to press down and cut any of the conductors inside of that outer jacket. And I'm going to go back and just run that knife just gently through there again to make sure that I have cut through the jacket. And if I take my fingernail here, I'm able to roll the jacket away from the inside conductors. Now the next step to remove the outer jacket, I like to use a sharp pair of very fine tipped flush cutters in order to trim the jacket away. So I slide the tip of the flush cutters in the jacket there, making sure not to cut any of the inside conductors, and just rotate the cord around in a circle as I remove the outer jacket very carefully without cutting through any of the conductors. And go all the way around by snipping that outer jacket, and that will be removed off of the cord. Now internally to the cord we have some nylon fillers here that help hold the shape of the cord. So we want to remove those, And again, by using our flush cutters, I'm pushing the conductors out of the way. I'm going to take my flush cutters and I'm going to cut the nylon filler out of the way. Also, there is some paper wrapped around in the internal jacket of the cord also that we will want to cut out. So go around and trim those nice and flush with the edge of the jacket that you just removed. This will make your cord very neat in appearance by removing all those parts that are not needed around that cord. And as you see, we have 3 conductors here that are sticking out the end. And again, we can look at this. We have the ground at the bottom, which matches our plug. We have the neutral over here on the left side of me, and the black on the right side. So those match exactly. So when we put those in the terminals, they will match up exactly with the terminals that they made up with. Now our next step is to remove the insulation of each of the conductors here that we're working with our extension cord. Now it's important to know what size conductor we're working with. So if you look on your extension cord, there are some numbers that are stamped into the side. Sometimes you will see that they are printed on there. The yellow cord here is stamped in the side of the jacket, and I will read those to you. So we have a Carroll, and that's the brand of the cord. This is a 3C, which means it's a 3 conductor. And then there is a 16 AWG. So the wires or the conductors inside of this cord are 16 gauge wire. And you will be able to look up inside your manual to find out what the current carrying capability of 16 gauge wire is. And then there's some other information here along with the UL notation. So this wire is UL approved. And there are some letters here that tell us that it is a water resistant SJTOW cord. And those letters again have some meaning about what type of conditions that this cord is suitable for. And you can look those up in your manual also. So the important part that I was looking for is the gauge of wire that is in our extension cord, and that is a 16 gauge wire. So I'm going to be using some wire strippers here to remove the outer jacket, and I will look on my jaws of my wire strippers here and select a hole that is marked 16 AWG. This is the proper size hole in order to remove the insulation without damaging the conductor. So I put my wire through that, I clamp down, and I release the pressure. I do not want to drag the jaws of the wire strippers along the fine wires inside that. And I'm going to use my thumb on the back side here to push and slide that insulation off the end of the wires. We do not want to exert a lot of force, so if you're exerting a lot of force, you did not cut around the entire wire there. So you may have a pair of wire strippers that aren't very good quality and making a good straight cut on the insulation. So again, I close my pliers or the wire strippers, and I then use the tool to help me slide that off of there by pressing that out. And again, I am not exerting a lot of force. And we're going to remove the last one here on the white wire, the neutral wire. And what we want to do is remove just enough insulation to be able to put our wires up in our terminal. Now, if you're not sure how much insulation to remove off the end, if you look at the end of your plug, there is some writing on here in the stamping. There is a place that says insulation and then wire. And if you look at that closely, that insulation versus wire, and if you would take a ruler and measure that, the wire part is about 1/2 of an inch. So you want about approximately 1/2 of an inch of bare wire exposed here. So if I take my ruler and check that, I've got very close to 1/2 of an inch on each one of those wires that I am going to put down in the terminals of our plug. The next step that we want to do is we want to twist those wires clockwise. So the direction that the clock hands turn, we want to twist each one of those wires and make sure all the strands are contained within that twist of wire. We also want to make sure and inspect that we have not damaged or cut any of the conductor and none of the strands are broken off and falling here on your work surface. If you do see that, you'll want to trim off the end of the wire and restrip the wire and start over with that process. If you damage that, you have reduced the current carrying capability of that wire, which is not desirable. So the very first terminal that we're going to install is the ground wire, which is the green one. Now if we look at our plugs here, our plug has plates that our wires are clamped in between. So the plates need to be open, and we're going to slide the wire down in the hole, and we are going to clamp those plates on the wire. So our goal is to get that wire in between the plates. All the bare wires should be under what we call the skirt or the insulator of the plug. So there should be no bare wires out beyond that are visible outside. This is also a clear body, so you should be able to look down in there and see how far your wire is going in between those connectors. We want the wire to go clear down to the bottom of those connectors, and also it's important that none of the insulation is pinched between the plates. So only bare copper wire should be between the metal plates on our plug. So as I slide that down, I can see through the clear body here of where my bare wire and the insulation meet up, and I'm going to use my Phillips screwdriver to tighten up the terminal here and just make it snug. I want to be able just to hold that in place, and again, if you take a look at that and inspect it, you should see that the wire is in between the two metal plates. The insulation is up to the metal terminal there, but not underneath of it, and only bare copper wire is under that connection. Now, we've snugged that up, but we're going to install the next two wires. So we've got the black wire, which is the hot wire, and I am going to slide that into the connection for the gold screw, and the neutral wire, the white wire, in between the connection for the white wire there with the silver screw. If you see that the wires get frayed while you're putting them in there, remove them, retwist them, and then work on sliding them down carefully between those plates and getting a nice connection with each of those wires. Now as that wire is in between the connection there, again, look through the clear body and kind of inspect that so you can watch as you tighten up the connection there. And again, for the black wire, just snug the connection up so that it's holding the wire firmly, but you don't have to worry about torquing down or tightening the screw really tight at this point. And then work on the neutral wire or the white wire, and again do the same process for that wire of turning down the screw and tightening up that connection. So once you have all those connections snug, once again re-inspect and make sure none of the insulation is under the terminal and there is no bare wire beyond the plastic insulation on the body of the plug. Our last step that we're going to want to do is we are going to want to place the plug down on your surface of your work table there that you're working on. I've got a board here underneath to protect my tabletop so I don't damage it. And then I'm going to take my screwdriver and I'm going to engage the Phillips head into my screw, and I'm going to put my hand on the back of the screwdriver, and as I turn I'm going to press down and turn. So when I tighten that up, I'm going to press down and turn. I'm going to use the force of my hand and the strength there to keep the tip of the Phillips screwdriver engaged, and we are going to torque that down and make a very tight connection for each one of those. So I'm starting with the ground, making sure that one is tight, moving on to the black connection and the positive wire there for the gold screw, and then lastly doing the neutral screw, which is the silver screw. And again, I'm pressing down and twisting the screwdriver. Now, you don't want to hold this in your hand and do the tightening of the screw, because if your screwdriver slips, you'll probably stick or stab yourself with the screwdriver, which may damage your hand and be very painful. So lay that down on your tabletop, put your screwdriver in place, and press down and twist. Now, if you don't have enough strength to be able to do that, you may need to stand up and use the weight of your body to press down and tighten that screw. So that completes the connections here at our plug. And in order to complete that end, we are going to slide the body of our plug cover back over. Now this has a key in it, and if you notice, there is a little dimple that sticks out. And if you look around on the edge of our plug, there is a little arrow on the side, and those two need to match up and they will slide together very easily. If you have to force it, you have not found the right position of that wire or the body of the plug with the body of the front of the plug there. And again, our screws here will be ready to tighten down. So we want to tighten down the screws at the end of our body again. These are coarse thread screws, so just a few screw twists there and those will tighten down. We want to make sure that we have a nice tight connection there with our body in the back shell. And the last part here is to inspect the end to make sure there is no conductors that are exposed, or when we close the clamp, we do not want to clamp on the wires. We want to clamp on the jacket of the cord. So mine has the body or the jacket of the wire that reaches down into the body of the plug just a little bit. And I'm going to again place this down on the tabletop here, and I'm going to use my Phillips screwdriver to tighten each one of these screws. And we want to tighten them evenly so that there is even pressure across that cord clamp. Now this is our strain relief device, or a cord clamp here for our plug. So we want to make sure that we clamp that down tight enough so that it is providing a strain relief, so that if somebody trips over the cord or accidentally yanks on the cord, it is not pulling on the conductors inside of the terminals here that are tightened down to each of the blades. What we do not want to do is we do not want to clamp this down so far that it crushes the conductors, but we do want a nice steady pressure there. So if you can see or move this cord in the back, you may need to adjust and tighten this up a little bit more on each one of these screws. And again, doing this by pressing down on your hand on the back of the screwdriver and twisting at the same time will keep that screwdriver tip engaged in the Phillips screwdriver slot for those screws. That will complete the male end of your extension cord, and next we're going to move to the female end and work on that. Now my cord here again is just an example cord, so it's very short, but this will give you the idea of being able to install the other end of our cord. So again, you should have a female end in your extension cord kit. And again, we need to loosen the screws so that we can insert the cord and remove the screws if they are tightened down in here, so we can remove the body of the plug on the female end here. And I'm going to loosen these screws up, but you do not need to remove them. And that will allow us to open up the cord clamp here and get our cord through the body and slide that through. Make sure that you install this first so that you're able to close that up after you install the wires onto the terminals here. And again, I'm going to remind you that we need to remove about 3/4 of an inch of insulation here. So if I put my ruler up here and mark 3/4 of an inch with my marker, I'm just going to put a little dot there so that I know that we are removing 3/4 of an inch of insulation. And again, I'm going to use my X-Acto knife here to cut lengthwise. And as I gently press down through there, I'm going to come back and make one additional cut to make sure that I'm removing the jacket only. and not cutting into the conductors. And as I take my fingernail here and roll my outer jacket back, I'm going to use my sharp side cuts, or my flush cutters here, to slowly cut around and remove the outer jacket for this end. Using the side cuts like that, or the sharp flush cutters, will give you a nice edge around the end of your extension cord and that jacket, so that it looks like you have done a professional job of removing it. And again, we've got nylon fillers within this end that we need to remove, and again, use the flush cutters. Now when we use the flush cutters, I've got a flush side here that I'm using to cut to the closest edge that I can of my jacket of the insulation around the cord. If I would turn them over, it would leave additional length out there, which I do not want, so I'm going to place the back side of those cutters up along the cord there and remove again that nylon filler. And our last filler here, I'm going to continue to do the same thing with that filler also. So that completes the removal of the paper insulation and the filler for this end. Now again, for this end, there is a diagram on here with a indication for the insulation and the wire. And again, the wire is approximately 1/2 inch that we need to have exposed. So 1/2 inch of bare wire. So if you look at how far you need to remove that insulation, again, this is a 16 gauge wire, so we're going to use our wire strippers. Clamp down and release the pressure. And you don't even have to use your tool to remove the insulation off there. You can use your fingers, and as you twist this, it will also twist the wire and remove it. That is one method to remove the insulation off of each wire. So I'll use that method on this end for you. So you can see the wire strippers are cutting the insulation all the way through, but not cutting any of the conductors in the cord. And my last wire here, the white neutral wire, again removing approximately 1/2 inch of that insulation. Again, you should not have any bare conductors that drop off on the table. If you do, or if you have several of them, one conductor cut may be acceptable, but several of them would not be acceptable. So if you see many wires coming off, you would want to clip that end off and restrip or remove the jacket and move that wire down that you're stripping a little bit past the end here, so that you don't have cut conductors that you're missing and reducing the current carrying capabilities of that conductor. And again, we've got colored screws here. So if you look, we've got a green screw that is here on our ground connection. Then we have a silver screw that is for our neutral, and a gold screw on the other side here, which is for our energized or our black hot wire. Okay, we are going to slide the conductors, and I'm going to adjust them here to get them so maybe I can put all 3 wires in those at the same time. And again, the colors of the wires are matching the screw terminals that we're connecting to. And as I hold the connector with one hand here, I'm looking through the clear body to ensure that I only have bare copper conductors in between the plates that I'm tightening down. Again, we're going to snug it with our screwdriver. And pay close attention to each conductor that you're tightening the screw down to make sure that you only have bare conductor in between those metal plates, and that the bare wire is in between the metal plates. These plates came from the factory already opened up. If your plug does not have the plates open, you may need to open them up beforehand. And to finish this up, we are going to re-inspect and make sure that our wires are in the proper place, and then set the connector down on your tabletop, and again use your hand to press down and twist, and then lastly press down one more time and twist. It should be very tight connection there, so none of the conductors are ever loose. That is very important to make sure that we have a good electrical connection. And we're using these mechanical screws to make that connection by making a tight mechanical connection on these electrical wires. So I've tightened up all three of those conductors, all three of the screws. And our last step is to install the back shell again on our wire. Now this one again is a keyed back shell, so there's a dent that sticks out there, and we want to find the arrow on the body and match that up, and those will slide together. And we're going to install the end screws first so that we tighten those up and get that installed correctly first. So use your Phillips screwdriver, and again those coarse screws will tighten that down and pull that into your body or the back shell very tight. Okay. And then our last step is again to inspect and make sure our outer jacket is down below the cord clamp here and into the body of the plug so that we don't have any conductors that are being clamped down on. And again, I'm going to set that down on my tabletop, and I'm going to connect those or tighten those screws to make that cord clamp grab or grip the conductor or the jacket of the wire there. And as we tighten that down, I want to tighten those evenly amongst the two screws that are there. And again, we want to inspect that. If I can still wiggle the back of the wire there, I need to tighten those down a little bit more. So as I see that my cord is wiggling or moving within the cord clamp, I did not get that tight enough. So I'm going to tighten those down evenly a little bit more. And I'm going to recheck that to make sure that we do have a nice tight grip on the back of our cord. Now that completes our wiring of our extension cord here, and so that gives you the installation of the male and the female ends. The last part of your project that you want to be able to do is you will want to write a note to explain what the intended purpose is of your project. Now the intended purpose is important for you to write down, not that you are going to use it to plug in a light or to run a piece of equipment, but it's important to know that you've selected the right size conductor for the intended purpose. So if you are going to run a vacuum cleaner, maybe a shop vac out in the garage, this would be a great project to do that because it's the correct size of wire that can handle about, if your vacuum cleaner is 10 amps, this 16 AWG wire would be able to handle 10 amps of current. Now if you had a device that you were wanting to power that drew 20 amps, 16 gauge wire would not be appropriate for a 20 amp load that would be connected to this. So the intended purpose is important for you to show the judge that you have selected the proper materials